Alright, so this week AI didn't just improve, it crossed a line. Meta released models that don't just understand data, but predict what happens next. At the same time, doctors began raising serious concerns about how tools like ChatGPT are already influencing healthcare decisions. In robotics, one machine forced the entire industry to rethink what robots are capable of, not in the future, but right now. Behind the scenes, teams like DeepSeek revealed a major architectural change that could shape their next generation of models. Meta introduced a new code agent that may completely change how developers write software. And Anthropic quietly moved AI into hospitals with Claude for healthcare. So in this video, we're breaking down everything that happened this week in AI. The breakthroughs, the warnings, and the signals pointing to where all of this is heading. Let's break down a quiet but important architecture change coming out of DeepSeek. So DeepSeek just exposed one of the biggest hidden inefficiencies in artificial intelligence, and their fix called ENGRAM might completely reshape how we build AI systems going forward. Let me paint you a picture of what's actually happening inside these massive AI models right now. When you type Alexander the Great into ChatGPT or Claude, something ridiculous happens behind the scenes. The model doesn't just recognize the name instantly like you or I would. Instead, it burns through layer after layer of expensive computation to reconstruct who Alexander the Great is from scratch. It pieces together clues like a detective. Ancient Greece, military conquest, famous leader, died young. The model assembles this understanding through dozens of transformer layers every single time. And here's the kicker. It does this even though it's seen Alexander the Great literally millions of times during training. The architecture forces it to rebuild that understanding from nothing on every encounter. It's like having a genius friend who forgets your name after every conversation and has to figure out who you are from context clues. Now multiply this by everything. Every famous name, every common phrase, United States of America, New York City, Princess of Wales. All these patterns are being reconstructed through heavy computation millions of times per second across every AI system on the planet. And DeepSeek finally said, enough is enough. Their solution is called ENGRAM. And the concept is beautifully simple. What if AI models had actual memory? Not conversation history memory. Real instant recall memory. The kind where you see Diana, Princess of Wales, and you just know who that is without any mental effort. The information is simply there, instantly accessible, requiring zero computation. That's exactly what ENGRAM delivers. It adds a dedicated memory module that stores common patterns and lets the AI look them up in constant time. Think of it like the difference between calculating 7 times 8 every time someone asks versus just knowing the answer is 56, because you memorized your times tables. Now here's where the engineering gets clever. You obviously cannot store every possible phrase combination. The number of potential word sequences is astronomical. So DeepSeek uses multi-head hashing. Imagine a massive warehouse with billions of organized shelves. Each common pattern gets assigned a specific shelf number. When the AI encounters a familiar phrase, it instantly jumps to the right shelf and grabs the pre-computed meaning it needs. But what happens when the shelf contains the wrong thing? What if the word Apple retrieves information about the technology company, when the conversation is actually about fruit? This is where the real genius comes in. DeepSeek added a context-aware gating mechanism. Every time memory retrieves information, there's a smart filter checking whether it fits the current context. The gate outputs a value between 0 and 1. If the memory matches the context, it flows through. If it clashes, the gate suppresses it. So the memory becomes a smart assistant rather than a blind lookup table. Now DeepSeek tackled the most important question. If you have a fixed budget of parameters, how should you divide them between thinking power and memory power? They formalized this mathematically and discovered a U-shaped curve. Too little memory, and the model wastes computation rebuilding simple patterns. Too much memory, and you sacrifice reasoning capacity. The sweet spot sits around 20 to 25% of parameters going to memory, with 75 to 80% dedicated to reasoning. For ENGRAM, 27 billion parameters. They reduced mixture of experts from 72 down to 55. And reallocated those freed parameters into 5.7 billion parameters of pure memory. Same total size, same computational cost, fundamentally different architecture. The benchmark results surprised even the researchers. Knowledge tasks improved as expected. MMLU climbed from 57.4 to 60.4. Chinese benchmarks jumped from 57.9 to 61.9. But here's the paradox. Reasoning scores improved too. ARC challenge climbed from 70.1 to 73.8. Big Bench Hard jumped from 50.9 to 55.9. Even coding improved with human eval going from 37.8 to 40.8. Math benchmarks like GSM-8K rose from 58.4 to 60.6. How does memory improve reasoning and coding in math? DeepSeek's explanation makes complete sense. In normal transformers, early layers burn effort on basic pattern reconstruction before the model can even begin reasoning. ENGRAM handles that boring work instantly through direct lookup. The model reaches useful representations much earlier. They confirmed this through mechanistic analysis. Layer 5 in an ENGRAM model behaves like Layer 12 in a standard model. The network becomes effectively deeper without adding more layers. That extra depth translates directly into better reasoning because early stages aren't wasted on trivial pattern matching anymore. Long context is where ENGRAM truly shines. They extended the context window to 32,000 tokens and compared against standard models. On Needle in a Haystack tests where you hide critical information inside massive documents, accuracy jumped from 84.2% to 97%. Variable tracking improved from 77% to 89%. When memory handles local patterns, attention becomes free to focus on global context instead of repetitive local stuff. The system efficiency results sealed the deal. Because memory lookup is deterministic, the system can predict what memory will be needed before reaching that layer. This enables prefetching in advance. They tested inserting a massive 100 billion parameter memory layer offloaded entirely to regular CPU memory. The throughput penalty was tiny. A 4 billion parameter model dropped from 9,031 tokens per second to 8,858. Worst case, only 2.8% overhead. You can bolt on enormous memory intelligence and barely impact speed. The researchers visualized how the memory gate behaves during inference. It activates exactly where you'd expect. On entity completions like Alexander the Great. On common phrases like Princess of Wales. Even on famous Chinese expressions. The model genuinely learns to use memory like real pattern recognition. The paper was co-authored by DeepSeek founder Liang Wenfeng, along with Peking University researchers. Both paper and complete code are fully open source on GitHub. Industry analysts believe ENGRAM will power DeepSeek's upcoming V4 model. If true, we're looking at the blueprint for next-generation AI systems. The broader lesson extends beyond this one technique. Mixture of experts was one innovation axis. ENGRAM adds an entirely new dimension by separating static memory from dynamic reasoning. The models that win the next phase won't just be bigger. They'll be architecturally smarter about what deserves computation versus instant recall. Sometimes the most intelligent thing you can do is simply remember the answer rather than recalculating it from first principles every single time. ENGRAM shows us a future where AI doesn't have to relearn what it already knows, but can instead look it up instantly, freeing up resources for deeper reasoning and complex intelligence. This is not just a code repository on GitHub. It represents a potential milestone in the evolution of artificial intelligence. DeepSeek just proved that sometimes the best breakthroughs come not from making AI think harder, but from teaching it to remember better. Next, let's take a look at how Meta is trying to change the way developers write code. So Meta and Harvard just released something that's quietly changing the entire game for AI coding agents, and honestly, the implications are kind of wild. This is the Confucius Code Agent, and it's proving something that most people still don't get about AI. The secret isn't always having the biggest, most expensive model. Sometimes it's about building the right system around it. So here's what just happened. Meta and Harvard dropped this fully open source AI software engineer called the Confucius Code Agent. And it's built on something called the Confucius SDK. Now, at first glance, you might think, okay, another coding agent, we've seen those before. Tools like SWE Agent and OpenHands already exist. But this is fundamentally different, and the difference matters more than you'd think. Most AI agents today are basically just large language models with a few tools bolted on. You give them the ability to run commands, edit files, maybe do some searching, and you call it a day. But Confucius flips that entire approach on its head. They're saying the system around the model, what they call the scaffold, is just as important as the model itself, and they've got the results to prove it. Here's the crazy part. When they tested this thing on real GitHub repositories using Claude Sonnet, which is a mid-tier model, it actually outperformed the much more powerful Claude Opus that had a weaker scaffold around it. Let that sink in for a second. A smaller, cheaper model with better scaffolding beat a larger, more expensive model. That's like saying a well-organized amateur chef can outperform a Michelin star chef working in a chaotic kitchen. The infrastructure matters. So what makes this scaffold so special? The Confucius SDK introduces 3 major mechanisms that completely change how AI agents work on real coding tasks. First, there's hierarchical working memory. This solves one of the biggest problems with AI agents today. They forget things. When you're debugging code, you might go through 50, 60, sometimes over 100 steps. You edit files, run tests, read error logs, try different approaches. In that long journey, decisions you made 40 steps ago still matter. But most agents just use a simple sliding window of context, which means eventually, that crucial information gets cut off. And once it's gone, the agent starts repeating mistakes, going in circles, breaking things it already fixed. It's like coding with amnesia. The hierarchical working memory system fixes this by organizing the agent's trajectory into structured scopes, summarizing past steps, and keeping the important stuff accessible while staying within context limits. Real memory architecture, not just a bigger context window. The second mechanism is persistent note-taking, and this one's honestly brilliant. The system has a dedicated agent that writes structured notes from execution traces. Kind of like the notes a senior engineer would leave for themselves after solving a tricky bug. These notes capture repository conventions, strategies that worked, patterns that failed, all the little gotchas specific to that code base. Then it stores them as long-term memory that can be reused across sessions. They tested this by running the agent twice on the same tasks, and the second time around, it solved problems faster, used fewer tokens, and wasted fewer steps. That efficiency improvement translates directly into cost savings in production environments. The third piece is modular tool extensions. Instead of treating tools like random function calls, each tool can maintain its own state and logic. Better tool handling alone boosted their success rate from around 44% to over 51% on benchmarks. That's a massive jump just from how the agent coordinates its tools. But here's where it gets really futuristic. They've built a meta agent that designs other agents. You give it a description in plain English of what kind of agent you want, and it proposes configurations, tests them on real tasks, looks at the results, and iteratively improves the design. The Confucius Code Agent itself was actually built using this meta agent process. We're literally at the point where AI is designing better AI systems. On the toughest coding benchmarks, like SWE Bench Pro, which has over 700 real GitHub issues requiring actual code fixes, Confucius Code Agent hit 54% success rate, absolutely crushing previous open source systems. To put that in perspective, it's competing directly with commercial closed source solutions while being completely transparent. On SWE Bench Verified, it reached 74% accuracy, outperforming other frameworks even when they used more powerful models. This proves the central thesis: smart scaffolding beats raw model power. What makes this particularly exciting for developers is the accessibility. This entire system is open source. You can customize the memory architecture, plug in your own tools, adapt it to your specific workflow. And because it works so well with mid-tier models, you don't need massive compute budgets to build production-grade AI coding assistants. The era of AI agents that actually remember, learn, and improve themselves is here, and it's completely open source. Let's start with the robot that just changed the industry. So a company most people have never heard of, just dropped something that could change everything. By the end of this video, you'll understand why Boston Dynamics should be very, very worried. But here's the craziest part. The price tag on this thing, it's going to make your jaw hit the floor. On January 12th, 2026, a Chinese company called LimX Dynamics unveiled something called COSA. And before you click away thinking this is just another robot announcement, let me explain why this is fundamentally different from anything we've seen before. COSA isn't actually a robot, it's an operating system. Remember when Android came along and suddenly every phone manufacturer could build smartphones? COSA is trying to do the exact same thing, but for humanoid robots. They're literally calling it the android of robots. And honestly, that comparison might actually be underselling it. Here's the problem that's been plaguing robotics for years. Current humanoid robots are basically running multiple separate AI systems that don't talk to each other properly. One system handles walking, another handles grabbing objects, another handles understanding what you're saying to it. It's messy, it's inefficient, and it's why most humanoid robots still look so awkward and robotic. COSA changes that completely. It's built on a 3-layer architecture that unifies everything into one seamless system. The foundation layer handles all the movement and balance. The perception layer processes what the robot sees and senses in real time. And the cognitive layer? This is where it gets wild. It handles decision-making, language understanding, task planning, memory, and get this, emotional states. Yeah, you heard that right. Emotional states. LimX is claiming their robots can manage something resembling emotional context. Now, whether that's marketing speak or something genuinely revolutionary, we don't know yet, but it's definitely something to keep an eye on. Let me paint you a picture of what this actually looks like in practice. You walk up to an Ollie robot, that's the humanoid that runs COSA, and you say, "Bring 2 water bottles to the reception desk." That's it. That's all you say. The robot then figures out where the water bottles are based on its memory of the environment. It plans the route. It navigates around obstacles. It picks up the bottles. It walks to the reception desk, and it delivers them. No pre-programming, no specific instructions. It just figures it out. And here's what really impressed me. If someone moves those water bottles while the robot is on its way to get them, it doesn't freak out. It doesn't crash. It simply replans in real time and adapts. That's the kind of flexibility we've been waiting for in robotics. Okay, let's talk about the elephant in the room. The price. Because this is where LimX just flipped the entire industry upside down. Boston Dynamics Atlas? Over $150,000, and they don't even sell it to the public. Agility Robotics Digit? Around $250,000. Figure AI's robots? Estimates put them anywhere from $30,000 to $150,000. The LimX Ollie humanoid running COSA? $21,800. I'm going to let that sink in for a second. A full-size humanoid robot standing 5'5" with 31 degrees of freedom, capable of walking on rough terrain, climbing stairs, carrying up to 8 kilograms, and running a sophisticated AI operating system for less than the price of a new Honda Civic. This isn't just competitive pricing. This is a declaration of war on every other robotics company on the planet. But here's why the price matters beyond just being impressive. At $21,000, humanoid robots suddenly become accessible to researchers, to universities, to small businesses, to developers who want to build applications on top of this platform. LimX isn't just selling robots, they're building an ecosystem. And if there's one thing we've learned from the smartphone wars, it's that ecosystems win. Apple didn't win because they had the best hardware. They won because they had the App Store. Android didn't win because it was the cheapest. It won because developers could build on it. COSA is making that exact same play, but for robotics. And they've got some serious firepower behind them. Alibaba owns almost 19% of the company. JD.com, which operates China's largest e-commerce fulfillment network, led their last funding round. SAIC Motor, China's biggest automaker, has invested too. These aren't just investors, these are deployment partners. JD.com needs warehouse automation desperately. So does Alibaba. LimX basically has guaranteed customers with massive logistics operations ready to deploy these robots at scale. The company has raised over $96 million in total, and they're already mass-producing these robots. This isn't a prototype announcement. This isn't a concept video. These are shipping products. Now let's zoom out for a second, because there's a bigger story here that's worth paying attention to. Chinese companies are absolutely dominating the humanoid robotics space right now. LimX, Unitree, Agibot, they're all pushing boundaries while American companies seem to be stuck in perpetual development mode. Boston Dynamics has been around for over 30 years and still hasn't figured out how to commercialize their robots successfully. Meanwhile, LimX was founded in 2022. That's less than 4 years ago. And they're already shipping production humanoids at a price point that makes competitors look ridiculous. The robotics industry might be about to go through the same transformation that happened with smartphones, with electric vehicles, with solar panels. Industries where American companies pioneered the technology, but Chinese companies figured out how to make it affordable and scalable. So what happens now? LimX is showing off COSA and the Oli robot at CES 2026. Pre-orders are already open. They're targeting logistics, warehousing, and manufacturing for the immediate future. As for household robots, the company's COO has been refreshingly honest about that. He says home applications are still 5 to 7 years away, which honestly, I respect. It's better than the constant overpromising we see from other companies. Look, I've covered a lot of robot announcements on this channel. Most of them are incremental improvements, cool demos that don't really change anything. This feels different. The combination of a unified operating system, aggressive pricing, massive strategic investors, and a clear path to deployment. That's rare in robotics. Will COSA actually become the android of robots? Will LimX deliver on these promises at scale? Only time will tell. But I'll say this. If you're not paying attention to what's happening in Chinese robotics right now, you're missing one of the biggest technology stories of the decade. This next one is important. Doctors are starting to raise concerns about how ChatGPT is being used in healthcare. Within just 4 days of each other, OpenAI and Anthropic launched dedicated healthcare AI products that promise to revolutionize how billions of people manage their health. But here's the thing nobody is talking about. One of these AI systems got 80% of pediatric diagnoses completely wrong. And yet, 230 million people are still asking it health questions every single week. By the end of this video, you'll know exactly which AI to trust with your health, which one doctors are actually recommending, and the critical privacy warning that both companies don't want you to hear. This information could genuinely save your life, so stick with me until the end. Let's start with what actually happened in January 2026. On January 7th, OpenAI dropped a bombshell. They announced ChatGPT Health, a dedicated space inside ChatGPT where you can connect your medical records and fitness apps to get personalized health advice. They revealed that 40 million people are already having health conversations with ChatGPT every single day. That's more than 5% of everything people ask ChatGPT about. But here's where it gets interesting. Just 4 days later, on January 11th, Anthropic fired back with Claude for healthcare. And they didn't just match OpenAI, they went after an entirely different market. Regular people who want to track their cholesterol, prepare for doctor visits, or understand their lab results. You can connect it to Apple Health, MyFitnessPal, Peloton, and even import your actual medical records if you're in the United States. Claude for healthcare took a completely different approach. Anthropic announced partnerships with some of the biggest names in medicine. Banner Health with over 22,000 healthcare providers, also with Stanford Healthcare. Memorial Sloan Kettering, one of the world's leading cancer centers. And pharmaceutical giants like Pfizer, Sanofi, and Eli Lilly. So we've got two AI titans. One going after consumers, one going after hospitals and drug companies. But which one is actually better at healthcare? Let me show you what the research actually says, and this is where things get really fascinating. When it comes to medical exam performance, ChatGPT dominates. A systematic review of 45 different studies found that GPT-4 achieved 81% accuracy on medical licensing exams around the world. It passed 26 out of 29 exams and actually outperformed the average medical student in 13 out of 17 cases. On the United States medical licensing exam, GPT-4 scored 81.5% on Step 1, 80.8% on Step 2, and an incredible 92.7% on Step 3. Sounds impressive, right? But hold on. When researchers at the University of Tokyo tested these AI systems on complex diagnostic cases, Claude told a completely different story. Claude correctly diagnosed 62% of difficult radiology cases, while GPT-4 only managed 49%. That's a massive difference when we're talking about real medical diagnoses. Another study in the Curious Medical Journal tested both AI systems across 14 complex medical scenarios. Claude scored 3.64 out of 5 for relevance and 3.43 for completeness. ChatGPT scored 3 out of 5 on both. Claude wasn't just a little better, It was significantly more thorough. And here's something that matters if you're actually trying to understand your health. Researchers found that Claude produces patient education materials at a 7th grade reading level with 69% understandability. ChatGPT writes at a 9th grade level. That might not sound like a big difference, but when you're stressed about a diagnosis, clarity matters. But before you pick a winner, there's a dark side to both of these AI systems that you absolutely need to know about. Remember that 80% number I mentioned at the beginning? A study published in JAMA Pediatrics found that ChatGPT had diagnostic error rates exceeding 80% in pediatric cases. 8 out of 10 children could have been misdiagnosed, and it gets worse. Both Claude and ChatGPT have approximately 16% hallucination rates. That means roughly 1 out of every 6 responses contains information that the AI simply made up. In medical contexts, that number can climb to nearly 29% according to research published in Nature Medicine. Mount Sinai researchers discovered something terrifying. These AI chatbots are highly vulnerable to repeating and elaborating on completely false medical information. They tested this by feeding the AI made-up medical terms, and both systems confidently provided detailed explanations of conditions that don't even exist. Real people have been hurt by this. There's a published case of someone whose transient ischemic attack, a mini-stroke, was misdiagnosed because they relied on ChatGPT. Another man developed bromide poisoning after following AI advice about his diet. The National Eating Disorders Association had to shut down their AI chatbot because it was giving potentially dangerous guidance to vulnerable people. And here's what might be the scariest finding of all. A study in the New England Journal of Medicine found that people couldn't tell the difference between AI responses and actual doctor responses. Worse, they showed increased trust in AI answers even when those answers were completely wrong. Now let's talk about the elephant in the room. Privacy. The consumer versions of both ChatGPT and Claude are not covered by HIPAA. I'm going to repeat that because it's that important. When you use the free versions of these tools, your health data is not legally protected. Dr. David Leibovitz from Northwestern University put it bluntly. Patients must understand that health data shared with ChatGPT is not protected by HIPAA. A researcher from Vanderbilt called it buyer beware. It's just a contractual agreement between you and OpenAI at that point. Both companies offer HIPAA-compliant options, but only for enterprise customers who pay for special agreements. The free versions that millions of people actually use? A doctor from Mass General Brigham advises you to assume that any information you upload will no longer be private. Here's what keeps privacy experts up at night. Neither company has disclosed how they handle government requests for health data. And here's something most people don't realize. OpenAI can change their terms of service whenever they want. Today they promise not to train on your health data. Tomorrow, that promise could disappear. The FDA has authorized over 1,250 AI-enabled medical devices as of July 2025. But here's the catch. Those are mostly for specific diagnostic tools like stroke detection and cancer screening. No generative AI mental health tools have received FDA authorization. The American Medical Association's position is crystal clear. Regardless of AI involvement, the physician carries final responsibility. AI is the tool, not a colleague. So after all this research, which AI should you actually use for healthcare? Here's my honest breakdown. If you're a regular person who wants to track your fitness data, prepare for doctor appointments, and ask general wellness questions, ChatGPT Health has broader app integrations and a more mature consumer experience. 262 doctors from 60 countries help train it, providing over 600,000 feedback interactions. The question isn't whether AI will transform healthcare. That's already happening. The question is whether you'll be informed enough to use it safely. Now, let's talk about Meta's new model that can predict what happens next, not just react. Alright, so Meta just proved you can teach a robot to understand physics, predict the future, and control robotic arms in completely new environments with just 62 hours of robot footage. This isn't science fiction, this is V-JEPA 2, and it's about to change everything. That's like watching YouTube non-stop for 114 years. But it didn't just memorize what it saw, it learned the fundamental rules of how our physical world actually works. Let me explain what makes this revolutionary. Most AI models predict the future by generating actual pixels, trying to recreate every tiny detail. Imagine predicting exactly how every leaf moves in the wind or how water ripples form. It's computationally insane and mostly pointless. V-JEPA 2 does something far more intelligent. Instead of predicting pixels, it predicts in representation space, learning the underlying concepts, the physics, the relationships between objects, not meaningless visual noise. This is based on JEPA, Joint Embedding Predictive Architecture, pioneered by Yann LeCun, Meta's chief AI scientist. The philosophy is simple but profound. Humans don't learn by memorizing every pixel we see. We learn concepts, relationships, and physical laws. A baby doesn't need to see a ball drop 10,000 times to understand gravity. They get it after a few observations because they're learning the principle, not the pixels. V-JEPA 2 has two components: an encoder that takes raw video and converts it into meaningful representations, understanding what's happening, a predictor that imagines what happens next. During training, they mask portions of video and challenge the model to fill in the gaps with meaning. The training happens in two brilliant stages. Stage 1 is completely self-supervised, no human labels, just raw internet video, over 1 million hours of diverse footage. From cooking videos to sports to object interactions, the model learned how objects move, how people manipulate things, how physics works, all without anyone telling it what anything was. Stage 2 is where it gets impressive. They added just 62 hours of robot control data from the Droid dataset. Just 62 hours. In this stage, they fine-tuned the predictor to understand how the world responds to specific robot actions. This action-conditioned training transforms V-JEPA 2 into a tool for actual robotic control. The performance numbers are staggering. On something V2, which tests motion understanding, V-JEPA 2 hit 77.3% accuracy, state-of-the-art performance. On Epic Kitchen's action anticipation, predicting what actions someone will perform 1 second into the future, it achieved 39.7% recall, better than any previous model. When combined with a large language model, it scored 84% on perception test and 76.9% on temp compass, both cutting-edge video question-answering benchmarks. But robotics applications truly showcase this world model's power. Meta deployed V-JEPA 2 on Franca robot arms in their labs, and these robots had never seen these environments before. For simple tasks like reaching or picking up objects, they give the robot a goal image. The robot uses V-JEPA 2 to imagine hundreds of possible action sequences, predicts which ones will get closest to the goal, and executes the best option. For complex pick-and-place tasks, they provide visual sub-goals, a sequence of images showing the steps. The results? 65% to 80% success on pick-and-place with completely new objects in completely new environments. No task-specific training. No environment calibration, just the world model working. They trained on robot data from completely different robots in different environments, then deployed on their lab robots without additional training. The model generalized across different camera angles, lighting, objects, everything. That's the holy grail of robotics, true generalization. Meta also released 3 benchmarks. INTOPHYS 2 tests if models can distinguish physically plausible from impossible scenarios. Humans score near perfect. Current AI models are barely better than random guessing. Minimal video pairs create similar-looking videos requiring opposite answers to the same question. Causal VQA focuses on cause and effect reasoning. These benchmarks reveal that while models describe what happened well, they struggle reasoning about what could happen or why. The implications are staggering. This proves Yann LeCun's vision that AI can learn about the world through observation, like humans, then use that understanding to plan and act in new situations. Think about the applications. Robotic assistants helping with household chores without thousands of training hours in your specific home. Wearable AI helping visually impaired people navigate by predicting pedestrian movements. Manufacturing robots adapting to new products without extensive reprogramming. Autonomous vehicles better understanding how other road users behave. What's exciting is Meta open-sourced everything. Model weights, training code, benchmarks, all on GitHub and Hugging Face. This isn't locked behind an API. This is genuine open science accelerating progress for everyone. But let's address limitations. The model struggles with long horizon planning, tasks requiring reasoning across multiple timescales. Meta's working on hierarchical JEPA models for this. It's also purely visual now. Future versions need audio, haptic feedback, other sensory modalities for truly comprehensive world models. And while physics understanding is impressive, there's still a gap on INTOPHYS 2. Humans develop intuitive physics as toddlers. V-JEPA 2 isn't there yet, though it's closer than any previous model. The competitive landscape is heating up. Google DeepMind has Genie, simulating entire 3D environments. Fei Li's World Labs raised $230 million for large world models. But V-JEPA 2 has crucial advantages. It's open source, efficient, and proven on real robots. The efficiency is remarkable. Compared to Cosmos, a competing model taking 4 minutes per action with 80% reaching success, but only 0 to 20% manipulation success, V-JEPA 2 takes just 16 seconds per action, hitting 100% on reaching and 60 to 80% on manipulation. The philosophical implications are profound. For decades, AI research relied on supervised learning, laboriously labeling datasets. V-JEPA 2 demonstrates self-supervised learning from observation. How biological intelligence works is not just viable but potentially superior. This connects to Yann LeCun's broader vision. He's argued for years that the path to human-level AI runs through world models, not just scaling language models. Language is compressed knowledge, but lossy and incomplete. The physical world, observable through video, contains far richer information about how reality operates. V-JEPA 2 puts this philosophy into practice. Meta positions this as foundational research toward AI agents genuinely operating in the physical world. Not chatbots or image generators, but embodied intelligence that can perceive, reason, plan, and act in three-dimensional space with all its complexity. Within a few years, we could see robots powered by world models like V-JEPA 2 performing useful warehouse, hospital, and home tasks. Within a decade, embodied AI assistants might be commonplace, helping elderly people maintain independence, assisting in disaster response, or enabling new remote collaboration forms. V-JEPA 2's release marks a genuine AI milestone. It's not hype or vaporware, it's working technology on real robots achieving impressive results. And because it's open source, thousands of researchers worldwide can now build upon this foundation. If you're a developer, researcher, or just fascinated by AI's future, V-JEPA 2 code and models are on GitHub waiting. If you're wondering whether AI will transform robotics and embodied intelligence, the answer is increasingly clear. It absolutely will. And V-JEPA 2 just showed us how. The robots are learning to see, predict, and plan. The future just got a whole lot more interesting. And finally, let's look at how Anthropic is bringing Claude directly into real healthcare settings. So Anthropic just launched Claude for healthcare, and what they revealed at the JP Morgan Healthcare Conference is absolutely mind-blowing. Let me tell you about that insane time reduction I mentioned. Novo Nordisk, one of the biggest pharmaceutical giants on the planet, started using Claude for their clinical study documentation. Before Claude, this process took over 10 weeks. After implementing Claude, just 10 minutes. Louise Linskov, their director of content digitalization, said this is setting a completely new standard for how medicines move from discovery to patients. But here's the thing. Novo Nordisk is just the beginning of this story. Let me introduce you to Banner Health. This is a massive health system in America, operating 33 hospitals and 400 clinics across 6 states. They serve over 1.2 million health plan members. And they built something incredible called BannerWise, an enterprise AI platform powered by Claude Sonnet 4.5. Now get this. They deployed it to over 55,000 employees. And the results? 85% of those users reported significant time savings alongside improved accuracy. But what really blew my mind was this. Oncology chart preparation, the kind of detailed and complex medical work that used to take 8 hours per patient, now takes just minutes. Since June 2025, they have processed over 1,400 oncology clinical notes through this system. Mike Regan, their chief technology officer, specifically said they chose Claude because of Anthropic's focus on AI safety. He mentioned something called constitutional AI, which is an approach designed to make AI more helpful, harmless, and honest. For a health system handling sensitive patient data, that trust factor was absolutely critical. Now I know what you are thinking. Sure, it is fast. But can an AI actually understand complex medical situations? Can it be accurate enough for something as important as healthcare? Well, the research data tells a shocking story. A study published in Nature Digital Medicine in 2025 examined challenging gastroenterology cases. Claude 3.5 Sonnet achieved 76.1% diagnostic accuracy. The 22 human physicians in that same study? They averaged just 29.5%. Claude outperformed every single doctor in that study. Let that sink in for a moment. For radiology cases from the Diagnosis Please quiz series, Claude 3. Opus achieved 54% accuracy on primary diagnosis. That is significantly higher than other AI models tested. And on complex diagnostic cases from the New England Journal of Medicine, Claude achieved 49.5% accuracy compared to just 27.4% for human medical journal readers. Now, before anyone thinks AI is about to replace doctors, let me be very clear. These impressive numbers come with important context. There is still around a 30% error rate on certain medical benchmarks, so Claude is not ready to make autonomous clinical decisions on its own. But for supporting physicians and handling administrative workflows, the results are genuinely remarkable. And speaking of administrative work, let us talk about something that affects every single doctor and nurse on the planet. Documentation. Physicians spend an absolutely insane amount of time on paperwork. It is one of the biggest complaints in healthcare. Doctors want to help patients, not type notes all day, and Claude is changing that dramatically. A company called Comure powers AI scribing for tens of millions of medical appointments. They report that providers using Claude-powered documentation save an average of 90 minutes per day. Think about that. 90 minutes every single day that doctors can now spend actually seeing patients instead of typing notes. At Medical City Dallas, part of HCA Healthcare, physicians generate 5,000 notes every week with an 18% reduction in documentation time. A company called Compassus deployed Claude across 8,000 nurses in 35 states and achieved 70% time savings in home health workflows. Dr. Palakirthi at Dignity Health saves up to 3 hours per day in the office, plus an additional 4 hours every weekend that was previously spent on documentation. These are not projections or estimates. Now let us address something crucial. Healthcare data is incredibly sensitive. So how exactly is Claude handling security and privacy? Claude for Healthcare is Anthropic's first HIPAA-compliant offering. For those unfamiliar, HIPAA is the strict American law protecting patient health information. They have business associate agreements available for enterprise and API customers. The security architecture is seriously impressive. They have SOC 2 Type 1 and Type 2 certification, which is the gold standard for enterprise security audits. They have ISO 27001 certification for information security management. All stored data uses AES 256 encryption, and everything in transit uses TLS 1.2 encryption. But here is the really important part that I want you to understand. Anthropic explicitly states that they do not use user health data to train their models. Health data is completely excluded from Claude's memory. Users can disconnect or edit their permissions at any time. Your medical information stays private. And Claude is the only frontier AI model available on all 3 major cloud platforms: Amazon Web Services, Google Cloud, and Microsoft Azure. This gives healthcare organizations the flexibility to deploy within whatever infrastructure they already use. Now let me tell you about the life sciences applications, because this is where things get really exciting for the future of medicine. Claude for Life Sciences launched in October 2025 and has expanded to support the full research and development lifecycle. A company called Flatiron Health does oncology research with Claude, and their analysis produced nearly identical real-world survival estimates compared to trained human researchers across 14 different cancer types. For clinical trial protocol development, Anthropic demonstrated Claude drafting a Phase 2 protocol for a hypothetical Parkinson's drug. The design time dropped from many days to about 1 hour, while still including endpoint recommendations, regulatory pathways, competitive landscape analysis, and FDA guidelines. Major pharmaceutical companies have partnered with Anthropic. We are talking about Eli Lilly, Sanofi, AbbVie, Genmab, and AstraZeneca. Emmanuel Frenehard, Sanofi's chief digital officer, said Claude is integral to their AI transformation. He mentioned they are seeing efficiency gains across the entire value chain, helping deliver life-changing medicines faster and more efficiently to patients worldwide. Apple Health and Android Health Connect integrations, Allow Claude to analyze fitness and health metrics from your smartphone and wearables. When connected, Claude can summarize your medical history, explain test results in plain language, detect patterns across your health metrics, and even help you prepare questions for your doctor appointments. Eric Abrams, Anthropic's head of life sciences, described Claude as the orchestrator of fragmented healthcare data. You can integrate your personal information with your medical records and insurance records, and have Claude simplify and navigate the whole confusing healthcare system for you. Now I need to be honest about the limitations, because this matters. Anthropic's policy requires that a qualified medical professional must review any content or decision before it is finalized for healthcare decisions, diagnosis, or patient care. This is not just a suggestion. It is a mandatory usage requirement. That's everything for this week in AI. If you found this useful, make sure to subscribe. I post clear breakdowns like this every week. Let me know in the comments which updates stood out to you the most, and I'll see you in the next one.